Hello everyone. In this video, we are going to discuss about the circular queue. So first of all, we will see what are the limitations of the simple queue and why we are going to implement the circular queue. So let's suppose this is your simple queue. In this queue, let's suppose we are inserting some elements 1, 2, 3, 4 and 5. These elements we have inserted. You know that the value of front will be 0, that is your index 0, and the value of rear will be 4, that is your maximum size, the maximum size minus 1. So here the value of r is the we can say max size minus 1, and max size is 5. So in this case we cannot insert the elements, it's okay, but if we delete some element from this queue, let's suppose I have deleted 3 elements in from the this queue. So front value will go on the 3 index. Now, in the simple queue, since the value of r is equal to max size minus 1, so we cannot insert the element. So that was the limitation of the simple queue. And to overcome this limitation, we will make this queue as a circular queue so that I can insert next value here. If I want to insert, let's suppose 6 now, I can insert 6 here. And the value of r will become 0. Again, if you want to insert next element will be inserted on the index number 1. And the value of r will become now 1 here. So in this way, we can make efficient use of the memory in the circular queue. So we will see now the algorithm of the queue. Here is the diagrammatic representation of the circular queue. This is like a simple queue only. You see here, you can understand from this queue that we have some elements earlier and the 3 elements we have deleted. So value of front will become 3 and the rear value is now 4. So if next element will go, it will go to the next element here, it will be inserted. So if you make it circular queue, so after 4, 0 index will come. So in this way you can represent the circular queue in the diagrammatic form. So let's see the algorithm for insertion. If you want to insert an element in the circular queue, how you are going to insert? Step number 1. Step number 1 is rear plus 1 percentage max. This percentage is your modulus. Modulus means the remainder operator. It means, let's suppose we have rear values 3. And if we substitute 3 here, and if we have max value is 5, then it will be 4 percentage 5. So if you find the remainder of this, it will be 4 only. Why? Because it is not divisible. The remainder will be 4 only. In this case, your answer is 4. So in this way, you are going to calculate the remainder. So what is this condition? Let's understand that. This condition we are writing to check whether the circular queue is full or not. If the circular queue is full, then we cannot insert the element. So there can be 2 scenarios where we can say that the queue is full. One scenario is very simple, like this 2, 3, 4, 5, 6. Here the value of r is here and the value of front is here. Now in this scenario, we can say that queue is full. So what is r? The value of r right now here is the index 4. So we will write here 4 plus 1 percentage 5. So if you calculate that, it will be 5 percentage 5. And the 5 percentage 5 is equal to 0 because there is no remainder. And the value of front is what? The value of front is also 0. So this condition is matching. That's why we will say Q is overflow. Means Q is full. Another case can be when we have this kind of scenario where we have inserted some elements and we have deleted 2 elements also. So this is front and this is your rear. But if we insert two more elements, 6 and 7, so your R will be in the circular cube will come here. So this is the another case where we can say that Q is full. So again we will apply this formula and this formula will give me correct answer. So let's apply the formula. What is the value of R? The value of R is 1 here. So 1 plus 1 percentage max. Max means maximum size of the array or cube. So it is 2 percentage 5. 2 percentage 5 will come as a 2. And what is the value of front? The value of front is 2. And 2 is equal to 2 is matching, means Q is overflow. So we are making the use of this reminder operator for getting this two kinds of condition. So any condition you come across like this, then we will say that Q overflow. But if this is not the case, then we can insert the element. So we will see the cases. Different cases can be there in circular queue also. Let's suppose first case is when queue is completely empty, where front and rear both are is equal to -1. This is the first case. Front is -1 and rear is also -1. Then if you want to insert the element, simply you can insert front is equal to rear is equal to 0. The pointer front and rear will come on the first position. And then in the step number 3, we can insert the Q of 0 is equal to value. So Q of 0 is equal to the value will come on the 0 index. Another case, which I will represent by else if. Else if we have rear is equal to max minus 1. Let's suppose we have rear is equal to max minus 1. Means your rear is here. Max minus 1 means index 4. Means your rear is here. And the front is not is equal to 0. Means your front will be somewhere else than 0. Let's suppose front is here. What is the meaning of this? Meaning of this is we have deleted one element and another element we have already in the cube. This is the scenario which I am talking in the second condition, that is rear is equal to max minus 1 and front not is equal to 0. In that case, what we have to do? Simply you have to increase the value of R to the 0. Means we have to set rear is equal to 0. And then finally I can insert the value at this location. So finally the Q of 0 will be your whatever value you want to insert. Last condition can be any condition other than this. Any condition other than this means anywhere we want to insert the value. For example, we have 2, 3. So in that case, the value of front is 0 and the value of rear is 1. So here just we will substitute the value now. The value of rear is 1. 1 plus 1 is 2 and 2 percentage 5 will be 2 only. That's why I'm just going to insert the value here. We'll increase the value of R first. Then I'm going to insert value at this location. So Q of 2 is equal to 4. And finally we will do exit. So this is the algorithm for insertion of an element in the circular queue. The rules are same only, that we are going to insert the value from rear end and we are going to delete the value from front end. Now we will see how we can delete the value. If you want to delete the value, you know that in the one condition we cannot delete the value, that is Q is empty. If front and rear both are on -1, then we cannot delete the value. That's why step number 1 is if front is -1, we will say Q underflow. And we will go to step number 4, that is exit. Step number 2, we are returning the value. When we return the value, basically we want to print the value that we want to delete. So let's suppose we have any scenario here like this, and we have some element. One element we have, you know that the front value and rear value will be on 0 when you have only one value. So if you want to return the value, you will first return the value q of 0. Again, q of 0 is 2, and 2 will be your derivative value. Then what we will do? We'll check some conditions. If front is equal to rear, if front is equal to rear, then we have to set front and rear both is equal to -1. Why? Because when we delete these two, we have to empty the cube. Basically, we empty the cube. That's why front and rear value both we will set to -1. And this scenario can come in any place also. For example, we have deleted two values. Let's suppose we have inserted two values first of all. So front is here and rear is here. And if we delete two values, then what will happen? To delete two, the front will come here. And again, if we delete the value, means we have front is equal to rear in this case. So if we delete again 3, I will not increase the value of front now. I will just reset the value to front is equal to -1 and rear is equal to -1. So these are the two cases. Or we can have any other case also where we can have front is equal to rear. What is the next case? The last is by default case. I think it's not by default case. This case I am drawing here. What is this case? Here front is equal to max -1. Front is equal to max -1 means our front is on the last index. On the last index, we have some value. Okay. Rear can be anywhere. Let's suppose rear is here. What is the meaning? Meaning is we have 3 more elements here. Okay, we don't care about rear. So if front is on the 4, the elements deleted will be 6, and your front we will set to the 4 because the front will come here after deleting the 6. That's why we are setting front is equal to 0. Last case is the by default case where we always do front is equal to front plus. So here, let's suppose we have some values 1, 2, 3. In this case, if you delete 1, simply you will do what? The value of front will be increased. So front is equal to front plus 1. So these cases I have drawn here. This is for step number 1, that is front is -1. Then we cannot delete. These two cases are for front is equal to rear. This case is also for front is equal to rear, where we reset the value of front and rear to -1. This case is your when front is equal to max -1. When front is equal to max -1, just we have to increase the value of front to 0 or reset the value of front to 0 because the next element after 6 we will delete is 4. This one is the normal case which we always do in the simple queue also, where we increase the value of front. So in the circular queue, in this way, we can utilize the maximum memory capacity. Now let's understand this example. Given the circular queue of size 5, perform the following operations on the circular queue. Insert 5, 9, 10, 13. Then we have to perform 3 times TQ. And then insert 4, 6, 8. And again you have to perform 2 times TQ. Initially, you know that the value of front and rear is -1. Then what will be the value of front and rear after the above operations? So we will construct one circular queue. This is circular queue. Actually, this node is connected to this node. Okay, so this is a circular queue. Initially, front and rear is -1. When we insert 5, the value of front and value of rear will come on the 0. When you insert next element, when you insert 9, then the value of rear will be increased. Value of rear will come here and we will insert 9 at this location. Size is 5. That's why index are from 0 to 4. If you insert next element, 10 will come here and the value of rear will be 2. If you insert 13, then first we will increase the value of R, then 13 we will insert. So this is your final after the 13 insertion. The TQ, 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 3 times you have to delete the element. If you delete first time, F will come here. Means your 5 will get deleted. If you insert, again you delete the element, second TQ we will do, 9 will be deleted, but value of front will come on the 10, on the 2 index. Again, third time if you delete, this value 10 will be deleted and the front will point to the index 3. Now, again we are inserting 4, 6 and 8. If we insert 4 here, the value of R will increase and R will come here and 4 I will insert on this index. So this will get, sorry, this is not deleted. This 13 will remain here only. What is next? This is circular cube. So 6 will be inserted now at the 0 index. So this R will become 0 after max minus 1. If you insert one more element, 8 will come here and the value of R will increase again. So the value of R is now 1. Then we will perform DQ 2 times. If you perform DQ 2 times, then this 13 will be deleted. And front will come here. If you delete once more, then the 4 will also be deleted. And the value of front will come on the 0. So finally, the value of front is, we can say front is equal to 0 and rear is equal to 1. And we have 2 elements in the list. So in this way, the working of circular cube will be there.